Hello, I'm Florian Quèze working for Mozilla on Firefox Power efficiency, and I will be talking today about Firefox Power profiling. I was expecting to be able to point to things on slide to show things in profile, but it will be difficult, so I will try to describe things, but bear with me. So content of the presentation. I will start by explaining why we are working on this, then what we could do to measure local power use, and this is how we ended up with wanting power profiling. And I will introduce the Firefox profiler, show what we can do with built-in profiling, and then explain external power profiling. I will have lots of examples throughout the slides. I will have links to the profile at the bottom, and I have links to my slides in lots of places so that you can actually click for the profiles yourself. So first, why are we working on this? There are three main reasons. First one is for sustainability. Mozilla made climate commitments, being carbon neutral, reducing our footprint, leading openly by sharing materials, tools, and methodologies, what I'm doing today, exploring approaches to develop, design, and improve products from a sustainability perspective, so making Firefox more energy efficient, for example. Second set, I forgot on this slide. One of the reasons why we care about power use of Firefox specifically is after looking at our greenhouse gas emission, it turns out use of a product on our users' computers is 98%. So it's really where we should focus our effort if we want to reduce our footprint. Second set of reasons is for our users. Even for people who think the climate is somebody else's problem, nobody likes to hear the noise of fans on a computer. Nobody likes to have a laptop burning their lap. And nobody likes to see their battery dying when they want to use the device. And last but not least, for a better web, because it's our mission. If you look at Mozilla's mission on the web page, it says we are building a better internet. And lots of details about what that means, but basically it's we are there to build a better internet. And all the tools we created to make Firefox more energy efficient, you can directly apply them to making web pages more efficient. So if we want to make anything more efficient, we are talking about optimization. And as always, when doing performance work, we should not be guessing, because we will be guessing wrong and spending our effort in a place where they will have no benefit. We should start with measuring. And we were measuring both locally and globally for our entire user population. I will focus the rest of this talk on what we do to measure locally. And if you want to know what we do about our global user base, you will need to ask me later. So first obvious way to measure power use of a computer is get a wattmeter. It's really cheap. It gives accurate numbers. It gives you a sense of how much power you're talking about and lets you compare to your fridge or other things in your house. It's not really useful for our use case because you can track evolution over time. So second thing is buy a better wattmeter that actually records the data and can export the data to a computer. It's much better, but still not so great because you can't really match the power use with what you are doing on the computer. So when I looked around, Microsoft was really very happy about bragging about how efficient Edge was made. That was many years ago when Edge was still a really separate browser engine. And there's one sentence here that I highlighted that's really interesting. Actually, Microsoft developed their own laptops just so that they could measure power use. Well, maybe not only for that purpose, but they included built-in power meters in their laptops. Could I get some of those laptops and check how they work? Sure. So I got two of those. The only two that I managed to find that actually have working power meters. There are many other devices that claim they have some of those meters, but they don't seem to physically be there on the main board. So I suspect they are used to prototype devices and then not actually installed. And we can see the energy meters in the Performance Monitor UI. So that's the thing highlighted in blue in the slide, in the bottom right. So we have a power meter for the CPU, for the GPU, for the Wi-Fi chip, and for something else I don't remember, maybe the entire system. We can look at this data in PerfMon. So this is what it looks like, Performance Monitor on Windows. In terms of UI, it's absolutely terrible. You can see the energy use there is 5 point a few more numbers, E plus 0.11, whatever that means. I don't know anybody who can use a UI like this. While looking at all of this and searching for machines with those power meters, I had some good surprise. Some machine reports energy meters there that have names that will feel familiar to some of you who are looking at server power use. Those RAPL underscore something, they are things coming from the CPU. And after some investigation, it turns out that Windows 11 has CPU drivers that expose them as energy meters. And the energy meter interface API, it's actually documented. We can use it, so we don't have to bear with the horrible performance monitor UI. Because it's documented, we know the unit. So this E plus 11, now we know that it was picowatt hours. We can query it many times per second. The overhead is low. It's accessible in user alone. No requirement to install anything specific on the computer. So we can use it for our profiler. Few days of prototyping later, this is what I got. So first profile I got with actual power tracks. So those are the three lines you see in gray. And the names are the same name as what we were seeing in Performance Monitor. So this shows us power use for the entire CPU package, for the CPU cores, and for the GPU. It was really not finished. The units were wrong. The names were not user-friendly. It was just good enough to convince me I should really get this thing going. And because it's the first time I show you a screenshot of a profiler, now is a good time to introduce the profiler and explain what it actually is. So, the profiler. It's built into Firefox, at least for the part that's recording the information. And we initially created it for performance work. And the reason for that is at some point we decided that our competitors having engineering teams 10 times larger than ours was not a good reason for Firefox to be slower. So we just needed better tooling. And the profiler helps a lot for users to produce useful bug reports about performance and for developers to make sense of those reports. It uses multiple sources of data. The main two sources are sampling. And by sampling, what I mean is at a fixed interval, we pause the execution of the software. We capture information about, for example, the execution stacks or the values of some counters. And the second source of information is markers. Markers is when the developer decided to record some event to be able to see at which point in time it happened, how often it happened. So if you want to use the Firefox profiler, this is where you go. Profiler.firefox.com. You can try it, it's really easy. You have this big blue button in here. You click it once, and you've got this toolbar icon that appears. It was already part of the browser, just you need to do this one click to enable it, because we don't want to show profilers to all of our users. In this panel, you can configure settings about how we will be recording things. The default settings should be good for most use cases, so you click the big Start Recording button. And now you see this. You do whatever it is that you wanted to profile. Very often it's loading a web page if you care about web performance. And then you click the capture button or press the keyboard shortcut, that's even better. And what happens is you have a new tab that opens that shows you everything about what you were profiling. So in this case, I was just profiling, loading the Wikipedia homepage. The link is clickable here if you have opened the slide, and you will have the link to the slides again soon. So I can show you the three main sources of data. And the reason why I insist on giving you the links to the profile is that it's a very interactive UI. You can move your mouse around. It's a bit overwhelming at first because there's data everywhere. It's a data-dense application. But wherever you put your mouse, you will see a tooltip appearing that tells you what is it that you are hovering right now. So here I was hovering almost in the middle, and we are seeing the stack of whatever was running at that point in time, which is some JavaScript here. Second thing is, if I lower my mouse a little bit and I go over the orange part, I see how much memory was used at this point in time. This is a counter, memory counters. And then if I click on the marker chart panel, I can see markers. So many things were recorded here. Markers like awake, they indicate whenever we were waking up the thread, which is useful for power information because waking up thread is expensive. Many other markers in here. So now that I've given some context about the profiler, I can start talking about what the built-in power profiling features support. So supported operating systems. I mentioned Windows already quite a bit in terms of APIs. So power profiling works on Windows 10 only if you've got one of those specific devices with built-in power meter chips. But as I said, on Windows 11, they included drivers for the CPUs that expose them as power meters. So it works on Intel and AMD CPUs. And in AMD CPUs even have the benefit of having one track per core, which helps to understand what was going on. We support Mac on both Apple Silicon and Intel CPUs. Differently, on Apple Silicon, there's an undocumented API that very nicely returns the information per process, which makes the profiles a lot more useful. And for Intel Macs, there's this very obscure system call that I suspect one of my former colleagues reverse engineered several years ago from a system tool, but doesn't require root access, so we can get the data. Linux, this was a difficult one, the one we got last, because it was trivial to access the data until October 2020, and then the data access was blocked due to a side channel attack. And the problem there is if you look at how much power is being used, you can guess what data was being processed at the time. Problem there is there's no limit into how often you can access the data on Linux. Other platforms limit to once per millisecond, and if you request more, it will return the same data again. So they decided to restrict it, and you need to be root to access all of the data. Or you need to run this one command here. That's the same command you would use to run the perf profiler, which is the Linux native profiler. And this is fine. We absolutely don't want users to run Firefox as root, but running something like this to enable profiling, this is fine. And then how to configure a profiler to use power profiling? It's very easy. I said before that you usually don't need to tweak the settings, so this is one exception. In the settings drop-down, you have a power preset that configures everything you want. And mostly what it does is trying to reduce the overhead by increasing the interval at which we sample, so 10 milliseconds instead of 1. Avoiding the capture of stacks for the threads, because that's also taking significant resources. And also, you can probably maybe see it in the list of features here, record markers for all threads. Because any thread could wake up at any time, and we want to know why it's waking up. So having markers for things wherever they happened, that's really useful. So now we'll start showing examples, and I hope you will make sense of what I'm saying without me being able to point to the places in the slide. There's a link to the slide again if you want to explore the profiles. So first, simple example, loading a web page. This is the Wikipedia homepage. And we can see process power tracks there. So I was profiling this on Apple Silicon. And you can see that the shape of those tracks, they match pretty well the shape of the things that indicate CPU use that I would be pointing to. So it's the gray area that you have in the line that's called parent process and the line that says wikipedia.org. So yeah, power use and CPU use, they match extremely well in lots of cases on the web. Another example here, this is just starting Firefox and seeing how much power it takes. I have a selection here, so you will see that some part of the profile is lighter and the rest is darker. By doing a selection like this and looking at the tooltip, I can see how much power, how much energy was used for the area that I selected. So in this case, we can say that starting Firefox used 10 milliwatt-hour on that specific computer. This is an example I really like because it shows how precise the measurement can be. Not sure if you ever wondered if it's using power to blink the cursor on your address bar. Of course it does, because it does something. And we can measure how much. So in this chart here, you see a few spikes at regular interval. Every 500 milliseconds, the cursor appears or disappears. And you can see how much it uses. But 1.5 microwatt-hour, I have no idea of what that is. Like, I can't give examples of what it is. It's so small. And by the way, we fixed this bug. So on most platforms, after blinking 9 times, it stops. Now it's time to take a step back. External power profiling, something we are shipping soon. So far, I've said we could measure the AC power by doing something on the socket. And this gives us the full picture of the entire computer. But we are limited because it's AC power, so we can't get more samples than the oscillations of the power. So we are limited to 50 samples per second, and that's very often not enough to see what's going on. On the other hand, we can get data from the CPUs, or system on a chip for the Apple case. This allows fast sampling, one sample per millisecond. It's really good to understand what was happening because in the profiler, we can align the power track with what was happening during that time. But it's a limited subset of the computer that we are measuring. And things like the disk or the screen, we have no idea how much they consume. Or many other things like the CPU is not the only chip on your main board. So what if we could profile the entire system? And the place where we would probably want to profile is the DC power. If you have a phone or a laptop, you have a charger. this cord, there's DC power going through it, and we can sample DC much faster than we can sample AC power. And it turns out it is possible. There are affordable devices that are sold as charger testers. So the purpose of those devices is to let you monitor how your charger is behaving. And for that, you need to be able to sample really quickly, because the point is to see if the charge is stable, if you've got stable current and voltage, or if it's changing for no good reason. Those devices are relatively cheap, and some can export the data to a computer through USB or Bluetooth. And this is why you see multiple cables here. So it's plugged into the phone, and the cable at the bottom is the charger, and the cable you see on the left side is actually plugged to my computer to record the data. And one interesting thing about how phone behaves with chargers is when the battery is full, they keep on using power from the charger for whatever else you are doing on the device. The reason for that is they want the device battery to be completely full when you unplug it. So they all behave this way, which means that if you wait for the battery to be completely full and you keep measuring how much power is delivered by the charger, you're no longer profiling the charger, you're profiling the device. And it turns out those devices support significant power. So many current laptops charge through USB-C power delivery, and you can just plug this device to the laptop. Those devices, I said they can export the data to computers. It's mostly with a closed-source software running on Windows. If there's any documentation for the API, it's really poor. Usually there's none. So it needs some reverse engineering. But we figured out how to support at least the device that I have on the slides here. And all the PCs we needed to change in our profiler, both the platform PCs and the front end, they are shipping Firefox 1 and 21, which is currently in beta. So should be shipping within about 5 weeks. And for all the future examples I will be showing, whenever you see a track that's called USB power, it means the power information coming from this power meter. So quick example, because the reason why I started working on this is I didn't have power profiling support for Android yet. And we have people who care a lot about power on Android, because this is where battery life matters the most on phones. You really don't want to be out of battery there. So you can see the USB power track here. So this profile is what we call a remote profile. That means that the profiling was started from my computer, but the profiler was actually capturing data on the phone. So when we capture the profile is sent to the computer so that we can look at it in the computer. And external power profiling here means that we are capturing power data from the external device. Also, the data is going to the computer, and the computer is merging the two sources of data to display it. So we can see here the shape of a power track. The baseline is relatively high at the beginning and at the end, and this is because the screen was turned on, and about 2 watts were used continuously. And you can also see that the shape of the chart changes similarly to the CPU use chart again. And we have a spike up to 7 watts while reading the Wikipedia page. So we can actually power profile what's happening on Android devices now. And now I have many more examples of things that we are seeing on the web, simplified test cases. This is something we shipped in Firefox, I don't remember the number, but basically on Windows 11, they started showing in the task manager this green leaf icon that's saying something is in efficiency mode. Initially, we didn't know what it meant, but after searching a little bit for it, it means that there's one process there that has opted to use the eco quality of service. What this does is it lets the operating system know that whatever this process does, it won't have visible user effects. So there's no reason to rush to do whatever it wants to compute, and we can take our time. So the operating system reacts by using the efficiency cores, if there are some, if you're on very modern Intel CPUs, or lowering the CPU frequency, which can be done on most CPUs. And we can see it on the power chart here. I'm using 100% of the CPU core in the content process in my test case. And you can see when the process priority changed because we switched the tab to being in the background, the power use dropped significantly. It was divided by 5. So this was probably the simplest fix we did that had the biggest impact on reducing power use of Firefox. Because users on Windows 11, there are lots of those. This is the same thing on Mac. On Mac, we have not shipped it yet because the API is more challenging to use, but we are experimenting with it, so there's a preference to enable it. The power impact is even more significant, and this time I was profiling also the entire machine. So you can see I have power use for the CPU, for the CPU cores and for the entire computer. And we can see a 20-watt drop, 20-watt drop in power use when I switch that tab to being in the background. So something I think we should really ship. So it's, this test case, it was just using the CPU for a full 1 second, just a loop that was waiting for 1 second to have passed and stop. So should not be a realistic use case. Well, it is when a website is abusing your sources, but other than that, it's not computing something useful. Here I have a similar test case that's actually computing something. So it's the same amount of computation done in both parts of a profile. The first one is in the foreground, the second one in the background. And in the table, we can compare how long it took. Obviously, it takes longer when we are in the background and lowering CPU frequency. How much energy was used by the CPU, significantly less in the background, and how much energy was used by the entire laptop during that time. And the surprise here, it used more power, because the laptop was on for longer. So this is why we don't always want to run stuff at low frequency. Sometimes it's better to rush to finish and then shut down the entire computer. This is an example I saw on a real web page. It was a very simple web page that looked to me like it was mostly text with a colored background. And I was distracted a little bit after putting this on my 4K external screen because there was a lot of text and I wanted to be able to read it. I think my cat was getting my attention or something. And when I came back, the laptop was super hot. And I wasn't sure why. Of course, I used the profiler to figure out what was going on. And I saw that we were painting continuously this web page. And I looked a bit at the CSS code, and it was actually animating the entire background of the page. And it looks like something trivial, right? It's just a few lines of CSS, simple animation. So when being a web developer, you might not think about it. But if you think about it as a graphics engineer, how many pixels do we need to compute to do this? So I said I'm on a 4K screen. So 4K horizontally, 2K vertically, that means 8 million pixels. Refresh rate of 120 Hertz. We are computing the color of 1 billion pixels per second. And that's assuming that we are not on a MacBook that's trying to do retina scaling and using an even larger rendering surface. And I was on a MacBook. You can see in this profile that for once the CPU use doesn't dominate. We have significant GPU use. We have significant DRAM power use. So this is using the memory. And all of those pixels, they need to go through the memory at some point, so it should not be a surprise. But it's one of the rare cases of profiling power where I can see the GPU using as much power as the CPU. And that's the thing you would typically only see when doing 3D video games or things like that. And I wanted to verify my assumption that it was because of many pixels being drawn many times. So I tried resizing the window to a smaller size. At the beginning of the profile here, I have a window taking all of my screen. At the end of the profile too. In the middle of the profile, I have a very tiny window, the minimum size I could get. And then after that, I have a medium size. And I extracted the data from the profile, so that's what you see on the right. And another thing worth noting is while resizing, the browser needs to redraw its UI, rearrange the toolbar icons, and all of that. And that's using CPU. So you can see that CPU power is actually higher while I'm resizing. And as soon as I stop the resizing, you will see the GPU power is significant compared to CPU. Second test, checking the refresh rate. There's a hidden preference in Firefox to limit the refresh rate. So at the beginning of the profile, it's doing 60 images per second. Then the second block you see, it's 30 images per second. The third one is 10 images per second. And the last one is limited to 1 Hertz, 1 image per second. And again, I measured power from the profile. So yes, that validates the assumption. It's many pixels displayed too many times. And now profile of playing a video. Without being able to point to anything in this one, it will be difficult, but basically it's pretty similar to the previous one. So it's mostly, so I had the video in a frame at the beginning, and then full screen, and then in a frame again. And we see that the animation when going full screen takes significant CPU power. We see significant RAM and GPU power being used while playing the video. And again, it's a matter of how many pixels we display, how often on the screen. And that video was displaying only 30 frames per second. So we can also probably guess that video decoding was efficient, so likely done on hardware acceleration. Otherwise, we would see a high CPU cost. And I don't know how I'm doing with time, but if I have a little bit more time, I have a few more things. There's a task manager in Firefox that you can open by going to About Processes. And there's a one-click profiling feature in here. If you hover over the name of a process, you have this profiler icon that appears. You do one click, it will profile everything happening in that process for 5 seconds and open a profile. So this is the place where you go when your laptop is hot and you are wondering which of your 100 tabs is doing something nasty. You can very quickly see it, very quickly profile it. The reason why I care about this is 10 years ago when I had former colleagues who were working on power use, when they had problems like this, it would take them a week to investigate, to figure out what was going on. Now when we are trying to figure out what's going wrong, it takes seconds, and then we start talking about what should we do instead, not what's going wrong. So this is why we developed those good tooling for power profiling, is because we don't want to spend our time figuring out what's going on. You might have seen in some of my tooltips, we show the CO2 equivalent for the power that was being used. This was a nice contribution from Chris and Fershad from the Green Web Foundation, so thanks for that. And something maybe I should not say, but it's tempting to say it anyway. We have power profiling support for most platforms. There are a few cases where you might not have power profiling possible, especially if you're running in a virtual machine and you don't have access to the hardware. As I said in the beginning, in most cases, CPU use and power use, they're almost the same chart. Not the same unit, but the shape is almost the same. With the notable exception of when you are animating so many pixels or playing large videos. But if you're mostly like loading a web page, loading JavaScript, loading CSS, it will be almost the same. And there's a relatively well-hidden feature in the profiler that makes process CPU tracks appear. So you open the DevTools console and type this command, and you will have a track for each of the processes, which might also be convenient if you are profiling on any platform where we don't have per process information for the power use. That's all I wanted to share for today. I have a link to the slides again if you want to look at the profiles and take your time to look at the examples, because I went very quickly. Do we have time for questions? Apparently, we have 3 minutes. OK. So while the mic goes to the person with a question, I will add one more thing. I have Firefox Nightly stickers that you can take at the end.
This one? Or this one?
So many mics.
Yeah, awesome work. And I was just wondering, do you recommend using that to improve performance? Or like, say, for example, if you take a look at other browsers where you don't have the energy metering in that regard, to just rely on the proxy metrics like CPU, GPU, what do you recommend in that regard?
Get Firefox. More seriously, one project we have for next year is to benchmark ourselves against competition. And we would like to check on which cases we are performing worse than the others in terms of power use. So we will figure out ways to also look at power use of our competing browsers. It might not be as easy, but we would like to have automation for that, because I want us to be the most sustainable browser. And I want also to be able to show numbers so that we can force others to react, because our mission is to make the web better. It's not to get everybody to use Firefox. But if we show that we can be more efficient than the others, they are forced to react and make their stuff more efficient, and then everybody benefits.
More questions? Anyone?
Hello. Thank you for the shout out to the Green Web Foundation. That's really nice. I should also know some of this because I'm doing the workshop tomorrow on parts of how to use a profiler. But you spoke a little bit about this being something you can run on a computer. And as I understand it, you could run this on a server as well, perhaps? Because if you're just looking at a computer, you're looking at just any program, you're looking at that details. Could you maybe talk a little bit about this being used on not just Firefox to see if you can profile other tools or other pieces of software?
So if I understood correctly, the question is, can we use the same logic that we have for power profiling to profile other software?
Correct, yeah.
Simple answer, yes. The way I've been doing it so far to profile our competing browsers is we have automated tests for Firefox, and some have no UI. And I have started the binary that we use to run automated tests without UI. And I started it with power profiling. And I've done something in Firefox, and then something in Edge, and then something in Chrome. And then I capture the profile, and I look at how much power was used at any time. And for example, we see that Edge uses the GPU a lot more than we do, and I don't know why. It doesn't change significantly the total amount of power, but we see interesting differences in terms of behaviors. And it's just something I did as a side thing to test, to verify that we could do things in the future. For it to be really useful, we would need to be able to command the browsers so that we could include markers in the profile to say what command we run at any time. But that's something we are working on and that I hope we will do next year.
Thank you.
Thank you very much. Any more questions? Great. Keep going. We're just waiting for track 2 to come down and join us. So it's a good opportunity.
Hi, have you considered to use the profiler also for WebAssembly on server side, maybe, or?
I couldn't hear all of the words, but I think the question was, could you use the profiler on the server side?
For WebAssembly.
For WebAssembly?
Yeah.
I guess I don't see why not. If we can profile any piece of software that's running, you can profile whatever you like, whether it's on a server or on a client. If you're asking specifically about power profiling, the problem you very often have on servers, it's virtual machines. And with virtual machines, we don't have access to the power metals.
No, bare metal, then basically running something in WebAssembly and doing power profile for it.
There should be ways to do it. Maybe they are not easy enough yet, but it should be technically possible.
Thanks.
Perfect, thank you. Is that everybody? One more. Okay, let's go.
Sorry, my apologies if you've mentioned this already, but is there any plans in the future to make this highly visible for the end user and not just in the hands of developers when developing?
So by making it highly visible, I assume you mean showing it when a web page is using too much power, is that correct?
Yeah.
We had plans for that in the past, and that's when we started working on that we started developing about processes. And the one thing that makes us not completely comfortable to do it is when a web tab is using way too much power, it's not clear if it's the website's fault or if it's our fault if we have our bug. And this is the reason why we have one-click profiling. It's because then within 5 seconds we can tell if Firefox is doing something wrong or if the website is doing something wrong. And I hope that we will fix enough bugs that we will be confident that it's always the website doing something wrong. I'm not sure if I can say that yet. I think we're in a better shape than we were 2 years ago. I think there's still some ways to improve.
Thank you. Thank you very much for the presentation. Thank you to everyone who's come down from track 2. Feel free to take a seat and we will let Max close before our drinks and canapes. So, thank you.
If you want Firefox stickers, I have many here.